In this workshop, we will introduce you to the tools you need to do Bayesian statistical analysis. The primary tool that you'll be using is called R. So before we launch into the specifics of how to use R, I'd like to give you some context of why R might be useful to you as a researcher. So first, I will introduce myself and my R journey, and then I will get into the specifics of what and why the R and RStudio software are. So, to introduce myself, my name is Katherine Muller, and I am an agroecologist, applied statistician, and data scientist, and hopefully I will see you in Abuja this January. I work with the DRIVES project, which stands for Diverse Rotations Improve Valuable Ecosystem Services. And this is a project I work with Dr. Frederic Viens on. And we put together data from long-term experiments throughout the country to study questions about crop rotation. And I want to point out that these last two parts of my career identity really come from being self-taught, and I don't really have much formal training. So I mean that to be inspiring. The formal training I do have, I should let you know. I have a dual bachelor's in biology and music and a master's and a PhD in plant evolutionary ecology. I did a postdoc in agroecology with legume cover crops, and I've used a variety of approaches throughout my research career. A smidgen, just a little bit of molecular biology from my work with crayfish in undergrad. I've done a lot of field lab and greenhouse experiments with plants and microbes, including some basic microbiology and um, some interesting plant physiology. For the past few years, I've mainly been focusing on Bayesian statistics, modeling, and complex data management. So my workspace is now pretty much entirely on my computer. So I started using R back in 2012. My first experience was a class during my master's called Quantitative Methods for Ecology and Conservation, which was basically applied statistics geared toward ecologists. And this was the first experience I'd had with any kind of coding or statistics. And it was a great starting point, but I have to say that 99.9% of my development has been really self-taught through books, freely available resources, and experiment experience. Oh, and while I'm showing this picture, this is me out in Minnesota prairies in 2012 collecting GPS data. So outstanding in my field, as I like to say. I have published uh, on pretty much all of my research projects, and I'll put a link to my Google Scholar page in the notes. And I want to mention that for most of my research papers, I've published some kind of companion paper that gives the data uh, and script, all the data in R code that went toward making all of the figures and results. So you can publish these things as a supplement to your paper, but the nice thing about using these data and code repositories is they are findable and they give you two publications for the price of one, which is pretty good. I've also delved into making an R package for my current project, which um, I will put a link to as well. This basically just, I was writing lots of functions and over, and I thought, oh, it would be useful to put all this in a package. So it was a lot easier than I thought it would be. So uh, even though I've been using R for over 20 years now, I'm still learning every day. Um, it's the projects that I do, my needs keep changing. R itself keeps changing. The syntax that most people use now called tidyverse, which you'll learn about in a little bit, didn't really exist when I started learning R. So a bit of a dinosaur that way. And I found that the skills I've used in learning R coding have really helped me branch out into other programming languages, which I only do if it's something that works better for the project that I'm working on. So I tend to use Python for, administrative tasks that operate through like other software, or JavaScript for Google Apps. So, but R is really still my home base and my first language in terms of programming. So I'm really looking forward to helping you learn R, and I hope it's as helpful to you as it has been to me. So now the specifics. So what is R? It is a computer programming language, and it is also an expansive set of tools for data science and statistics. So R is really the lingua franca for statisticians, and most of the tools developed, a lot of the advanced statistics tools have really been developed in R. Another really similarly large set of open source tools is the Python language, and there's a lot of overlap in the kinds of tools developed for both platforms. But the main difference is just that R tends to be more widely used by statisticians, and Python tends to be more widely used by people who call themselves who do machine learning. I don't mean to insult machine learning, but I'll get a little into the distinctions between those two things in another video. But basically, I can say that learning one makes it really easier to learn the other. They both have useful features, but we're focusing on R because that's where a lot of the statistical tools are useful. Let's see. So another good reason to use R, it's free. And it's not just like, oh, free to use, but we'll sell your information to all our advertisers. It's actually truly free. Nobody's making money off of you. It's actually an open source tool. This means that it can be freely shared and modified by anybody. So if someone thinks, gee, I wish I could make R do X, they can contribute code to make R do X. So there's a global community of users that are developing tools for their own projects and then passing on those tools to everybody else. And since R has been around for statistics, a lot of the tools for statistics are in R. So another good reason to use R is that it can basically do anything you could do with code. So it's useful for manipulating data. I use R to organize messy data sets and put data together and build databases. It's great for making data visualizations. Let's see. So I want to point out this site, the R Graph Gallery, which has a lot of examples of the kinds of visuals you could make in R, organized by the kind of information that they convey. And this all leads to, there's always source codes and packages and tutorials. It's quite helpful. Um, it's useful for analyzing data and making statistical models, that as you will be doing for this workshop. It's also useful for doing data simulations, which is very important as we get into Bayesian statistics, which involves a lot of uh, simulating statistical models and generating random statistical draws. R has an inbuilt random number generator, so that's very helpful. It's great for making documents to communicate your science. I want to point out this other resource, the R Markdown Gallery, that I have up here. This just gives some examples of the kinds of documents you can make using R, including, just like reports or websites, interactive documents. It sometimes helps to see an example that gives you a template, or there are actually templates that you can take and reworked for your own purposes. So yeah, a lot of resources out there. Um, R is very useful for automating tasks. I especially if you have something that's really tedious to do. Like let's say you have to open an Excel file and like move columns around and like identify, oh, here's a this here's a mistake and this shouldn't be a number greater than 10 million or I don't know. But um, a lot of the tasks that might be a lot really tedious, if you can write an R script to do it, then you don't have to do it again. You can have R do it for you, which is very nice. Let's see. And so a lot of the functionality of R and why it's so versatile comes from what is called packages, which it's kind of like an app for your phone. It's just a little piece of um, a little code module that you can download and install and comes with all kinds of useful functions. And what's also cool about packages is anyone can make one and distribute it. I wanted to share a few fun examples of our packages. One is called the Soil Palettes package, which I found when I was using R to make some visuals for a conference poster. And I thought, gee, wouldn't it be fun if the soil depth was colored to mimic soil horizons? I wonder if there's a package for that. And sure enough, somebody made one. So I thought it was pretty fun and very simple to use. Another fun package that is not so practical is called Cowsay, which is basically just a way of making text art animals say what you want. It has no practical function, but sometimes fun packages can be helpful for learning the fundamentals of how to use R code. Like this has, it has arguments, it has functions, and developing packages like these can be really good programming exercises. And if they're fun, sometimes that helps with the motivation. So why use R? Another good reason, of course, is reproducibility. In science, it's really important that other scientists be able to reproduce your results to confirm that they're valid and trustworthy. And it also, that increases the impact of your science as well. So if your analysis is done in R, you can share your code and your data, and you can show exactly how you arrived at the conclusions you present. So I think of this as analogous to having a robot chef. So you write the recipe, the chef cooks it for you, and if it doesn't turn out well, you can look through your code and see, oh, maybe I made a mistake somewhere. Oh, in this line, I accidentally told the robot to add 5 grams of salt instead of 0.5 grams, so I'll just move that decimal point over and, now it's good. And my friend comes over for dinner, loves what I made. I can give them my script, my recipe, and they can have their robot chef make it. And maybe they might decide, oh, this is great, but what if we made it a savory pie instead of a sweet pie? And they can build on my code and make it do all kinds of new things. So this is how innovation happens, but also it's really helpful for just documenting your work for yourself and for others. All right, another very valid, good reason to use R is that there's so much information on learning R available freely, an extensive community. The Posit company that develops RStudio, which I'll get into momentarily, has an RStudio education page that has lots of resources. Um, if you run into any kind of problem and Google it, you'll probably find a Stack Exchange thread where people have ask the same question and provide solutions. There's a lot of publicly available books people have made. Pointing out a few here, R for graduate students, R for data science are both great resources for beginners. And the Advanced R book by Hadley Wickham, I really liked it as a way of getting into R as a computer programming language. So if you're from a more of a computer science background, it's super helpful. There's a bajillion free online courses and, of course, lots and lots of YouTube videos. So if you want to learn how to do something in R, you can probably find a tutorial on how to do it. So now, pivoting from R to RStudio, these are actually two separate things. So RStudio is what's called an Integrated Developer Environment, or IDE, which just means it's an environment that you use to work with R. So I think of it as analogous to a car, where RStudio is like the seats and the steering wheel and the dashboard, like everything that you as a driver interact with. And then R is, the engine that brings you forward, that is under the surface. And similar to the car analogy, RStudio has a set of tools that uh, expand on beyond R itself, that help you really ease your workflow. So, for example, it's analogous to like having the radio or the air conditioner, and we'll get into some of those tools are. So, RStudio comes in several forms. So, the one that you'll be using is called RStudio Desktop, and this is a software application that you download and install locally on your computer, and it uses the files on your hard drive. Everything's, it also can connect with internet files, but you have to give it some kind of address. And then it is free and open source, which is great. There's another resource I just want to mention because it might be useful to you, but we won't be focusing on it in the course, is called Posit Cloud, which is an online software that you run through your browser, and so there's no need to install anything on your computer. And everything, all the files it interacts with are on some kind of cloud server. But because of this and the cloud nature, server space costs money. So there's tiered access, and you have to create a user account, and it's free to use with a certain level of data and number of projects. And then there are paid versions. Um, so as I said, we'll be focusing on RStudio Desktop for this course. Um, so more reasons on why to use RStudio. As I mentioned, it's free and open source, although Posit does offer various paid subscription options for Posit Cloud. There's some RStudio versions that you run on servers, but for your purposes, you can consider it free. And RStudio really makes a lot of complicated coding tasks easy and accessible for people without a computer science background like myself. It has tools to help you make packages, tools for using version control with Git and GitHub, which I will discuss in another video. It has a lot of templates for various kinds of documents, and it has integrations with other programming languages. So you could use RStudio for Python, for making Markdown documents. Um, it's really kind of a general purpose IDE that arose from R and is still centered on R, but um, yeah, can use it for other things too. So that is the end of this video on the what and the why. And so next, I will be showing you how to set up R and RStudio on your computer for the first time, or if you already have it, how to update it. All right, see you then.